That's a really good transition because we need to get to our next speaker. I want to thank Anthony and Dr. Chandra. Listen, I grew up on a farm. My dad was a farmer, but when you're a farmer, you're also an engineer, a mechanic, a marketer, all the things at the same time. And I know that Andrew Bish, who is going to be talking to us about some of their experience as a fabrication company within the space of specialization in specialized crops. I know his family history is on the farm as well. As I mentioned at the beginning of our call this morning, his grandfather actually held a patent for the first specialized corn header, as a matter of fact. So this said, let's turn this over and let's talk about small scale mechanization in cultivation. Andrew, the floor is yours. I cannot give you a better introduction than that.
Well, thank you, Nate. Can you hear me?
Oh, yeah. Well, I'm sorry. One other thing. Andrew's mother makes mean Indian cuisine.
Oh, okay. So hold on. I've got your um, technology issue going on here. Bear with me just a second.
That's all right. Not a problem. As I mentioned, Andrew and his brother are third generation fabricators. His dad is a Nebraska Lead alum, an organization that I'm an alumnus of as well. Tracy Zink, who's on the call, is also an alum. So they tend to do good work, I think, in producing leaders within the agricultural space. But Andrew's a very, very brilliant guy, and I'm very pleased over the last few years to get to know him better and consider him to be a friend as well. Andrew, if you need me to tell any jokes, I can do that.
Okay.
While we wait.
So
Maybe
let's see.
juggle.
Um,
And I did download the presentation that that Ankit made. That Anthony made, as well as the document that Ankit dropped on the irrigation practices in Central America. And I will make sure and share that out. I'll share those materials out when I share a copy of the meeting recording, which will probably be later this evening or tomorrow by the time I get the video processed. And Eric asks how long I wanted him to wait to put a pin in it. First of all, thank you for your patience, Eric. Second of all, let's let Andrew go ahead and present, and then I'm really looking forward to just sit back and hearing the conversation between Eric and Andrew, quite frankly, two folks who are working in this space. Is that all right? I hope that's all right with you, Eric.
yeah, can you hear me now?
Yeah.
Okay, so we're gonna do this a little bit wonky. So when I'm talking, you won't see my face. I've got two videos going on, but I apologize for that.
You're fine.
I will share my.
We're all happy with that outcome.
Thank you, Nate. Thank you, Nate. I appreciate that. Okay, so let me just share my screen here. And I'm gonna presume we can see my screen. Is that right?
Yes, we can see it just fine.
Okay, well, great. Nate already talked a little bit about who I am. Yeah, I operate a couple different companies out of central Nebraska, Bish Enterprises, and then we got involved in the hemp industry before it was legal. So we also have a company called Hemp Harvest Works. I also serve on a number of nonprofit associations based around agriculture in my spare time. My grandfather started our company. We were founded in 1974. And what we set out to do, or what he set out to do, was really just solve some of these challenges that producers in the United States were having as we were moving into mechanization at that period in time. Where are we? So we are in a little town known as Giltner, Nebraska, in the center of the state. I call it the center of the state. You'll notice it's not actually the center of the state, but that's how we see ourselves, is right in the center there. Just a little over an hour from Nate's location, which he resides in Lincoln. But we serve a lot of the Midwest. Nebraska is not our typical clientele, but our reach spreads all the way throughout the United States, and then we do export some items as well. So what do? We work with farmers, producers, equipment dealers across the country to solve complicated issues with inexpensive solutions. We have an engineering department. We can create new design ideas, engineer products. We have a fabrication facility. We can do prototype or production scale equipment. We do CNC plasma cutting, bending, those types of things. We also do assembly right on site. We sell our own products. We ship our own products, and we have our own office personnel. We're a team of about 22 team members in Giltner, Nebraska. We are the second largest employer in the little town that we're in. Our town has 400 people. The only larger employer is the school system. We do 3D engineering or 3D design work using SolidWorks, and then our engineering team also works with that software. That's all done. A lot of that is done in-house. Like I mentioned, we are capable of doing any type of plasma cutting. We've got local laser cutting services as well. We bend our own parts. We work a lot with steel, aluminum, a lot of sheet metal and tubing are our specialties. Those are agricultural components are oftentimes built with tubing and sheet metal. Have our own team of fabricators and welders and assembly team members. So what do we do for products? We're most known for our header adapters. I'll show you some of these items here in just a little bit, as well as some of our other products. We'll just get into some videos. So header adapters, this is really what started our company. My grandfather saw a need out there to reduce the entry cost to farmers wanting to upgrade a combine and not necessarily wanting to upgrade their header. Now I realize that some of this equipment is larger scale than what some of the conversations we're having on this call are, but I think that when we look at what we do as a company, this adaptation is a relatively simple item that helps customers, helps farmers specifically be able to more affordably harvest their crops. And it does seem like there is, from at least the dialogue we've heard today, some opportunity there. The adapters to me just symbolize our ability to make different components work together. And I think when we're thinking about how do we get different manufacturers and different products that are in the marketplace to play nicely together, we definitely have the ability to source some of that out. Here's some other adapters that we make. So if you ever see, if you're in the United States and you ever happen to see any crop videos where there's different color headers on different combines, we likely made the component for that. Here's just a short video of some of the one of the products that I guess we put together a few years ago for the AGCO Corporation. You can see from the background we are in farm country. There happened to be a sprayer running in the background of that one, the snippet just a minute ago. So sorghum, this is, I guess, what brought Nate and I together. We happened to develop a specialty header specifically for the harvesting of sorghum. It is called our super crop header. This header was designed to more efficiently harvest sorghum in some of the drier parts of the United States. A lot of the research that went into this header was done in eastern Colorado and western Kansas, where there are some sincere drought conditions that have been ongoing for long periods of time. One of the challenges we were trying to solve when we developed this particular header for sorghum was that, at least in the United States, a lot of our varieties tend to fall down in the during the harvest period or before the harvest period and end up on the ground. We wanted an efficient way to pick the material up without bringing all of the material into the combine, so that we put less workload onto the combine, use less fuel, but also capture that material that would otherwise be lost as a result of the weather situation. This is another product that we innovated, developed out. This was for actually one of our specialty crop customers that works in hemp. We wanted we were working to identify a way to make it easier for farmers that had traditional raking and baling equipment to be able to cut down the hemp plants, the stock. These are customers that are harvesting for stock material. We wanted an easier way for them to be able to rake and bale that equipment using their existing the existing equipment that they already have on site. So we ended up developing this multi-level sickle mower system. Pretty simple technology, old technology. Sickles have been around for a long period of time. But the way that we configured it allowed it to work for a more efficient harvesting system. So we are very familiar with working not only with new technologies, but older technologies and how to apply those to today's needs. This is an example of a smaller scale piece of equipment that we've developed. This is a research scale decortication unit. So this actually takes stalks, specifically currently of hemp or canaf plants, and it can separate out the bast fibers from that stalk material, so they can separate out the hurd or the woody material from those bast fibers. And this machine was really designed for universities in the United States, where they're doing small scale plots, trying to understand the different ratios of what is inside of the stalk itself. A machine like this could easily be used for a small grower as well. And those are some of the things that we're actually working on right now, is modifying the unit to work a little bit more efficiently with a smaller grower instead of a university setting. But that's just an example of some of the smaller equipment we're fully capable of building, as most of what I've shown before is pretty large scale. This header here was designed for the wild rice industry. We've got another one going into production right now. This is a specially designed header with an extremely large reel. The reel happens to be over 100 inches in diameter. There's not any other headers on the marketplace that have such a large reel. But again, we're trying to solve some of the challenges and that these producers are having when harvesting wild rice. Wild rice is also a crop that tends to fall over. About 30 to 40% of the crop is oftentimes laying over in the field when the producer harvests it. Wild rice also shatters very easily. It's a wild crop, so they haven't bred shatter resistance into it. And so the oversized reel, what it does is allows us to stay above the seed head when harvesting at very low points, reducing the amount of shatter that occurs with that plant. And then when we get into some smaller equipment, we do a lot of work with researchers throughout the United States, seed companies that most of the seed in the world is created by some of these companies, but these lend into some of our smaller headers. So we've got 2, 3, 4, 5-row, 6-row headers that we've designed for this type of purpose and could potentially work well in locations that have small scale equipment. Now, even these videos here, obviously, this combine is larger than what we'd be seeing in a lot of areas, but just examples of the ability to take large scale equipment and scale that down so that it can be used in a smaller setting, but still have some of the efficiencies that are achieved from the larger scale style equipment. Just another example, small plot combine. These combines that you're seeing in the videos are much smaller than what a typical person in the United States would use for production purposes. But I have seen similar sized combines in places like India. And that's a little bit about what we do. So let me stop sharing here. And we'll get back to, let me see if I can show my video now.
Yeah, while you're doing that, Andrew, looks like we have a couple of questions in the chat, but I also want to make sure that we have time for you and Eric to have a healthy interchange. I'm really excited because it sounds like he's doing some really cool things. I know you're doing some really cool things. And I love putting two engineers together and just sitting back and watching. But before we do that, Michael Snow asked just how far you can scale your work down. And then he wanted some clarification on the Winter Siger combine as far as cost is $70,000 or more. So if you can address those things, and then Eric, it'll be time to take the pin out of it.
Yeah, I think that's a great question that we had about what the costs of those machines are, and the reality is a lot of those combines are still out of reach for a lot of producers out there. That Winter Siger combine right there may very well cost in excess of 150 to 200 or more $1,000, depending on how that's set up. And that's definitely not something most people can tolerate. The good news is those combines are very complex in terms of their research capabilities. So there are less expensive combines out there in the marketplace. Now, how far can we scale this down? Quite a bit, actually. It really just, for us, it just depends on what the need is and understanding what you're trying to accomplish. You can get, I heard a lot of discussion earlier about threshers. You can make threshing systems very small, very compact. We can do the same thing with mechanized headers. We've seen equipment that can go on self-propelled machines and self-propelled walk behind machines, for instance. So we do have the capabilities of scaling all the way down to that type of equipment if necessary. I think one of the challenges definitely is always that price point and making it desirable for people, but also affordable. And that's where we at least for our company in the United States, that's been our space, is trying to figure out how do we make things affordable and solve a problem. And while I definitely don't have a solution to all of the challenges we've discussed today, we're a very open-minded group looking at how we can do just that.
And follow-up question from Michael. He asks, at what cost and what kind of market? This is a very important one, I think. What kind of market would you need to actually produce it? Like, what kind of market makes sense for you to enter into that space?
Well, obviously you have to have offtake. I mean, that's always the challenge with any crop that's going to drive that type of equipment is having enough offtake. I wouldn't prescribe for a lot of the places that we're talking to today to use the type of equipment that I just showed in those videos. I don't think that the supply chain is necessarily developed out in a way that the price point can sustain that type of equipment right now. What I was trying to showcase is simply just what our capabilities are in terms of producing equipment from small scale or large scale, that we are capable of doing that, and that there are companies out there interested in trying to work with people to solve these problems. Much like you said very early in this conversation, Nate, I'm not sure what all the solutions are, and I've been listening to all of the dialogue today, trying to better understand the problem to figure out, what are the pieces of this that makes sense to focus on in terms of trying to solve.
Yeah, thank you. That's a really good answer. And again, that's the point we're trying to make today is just listening and having those conversations. It's tempting to want to jump into solutions, but we have to start with understanding because everyone's situation is a bit different. Okay, so with that, Eric, I wonder, and screen share is enabled. Do you have any video or website or anything like that of your equipment that you could share with us? And even if you don't, I'm really interested just to, again, to sit back and let you and Andrew have a conversation that engineers have around these problems. I think that's interesting.
Well, thanks, Nate. I really appreciate you have this open-mindedness and receptiveness that is sometimes hard to find when you are looking at disruption. And we've been at this long enough to begin to believe that we must be holding on to something that is somewhat disruptive because it is sitting outside of the box of where most people are thinking, and it's sitting outside of the ecosystems that most people are trying to copy and paste into Africa. And it's difficult because those ecosystems will work in other regions, but they don't necessarily work in Africa. And it's all about how can we plug into an ecosystem and perhaps modify business as usual in such a way that it is working better for local context. And that's been one of the biggest problems in Africa. So I have some slides I can screen share. I'm gonna have a ton of slides, but I think I'd just like to give as brief of an overview that addresses some of the concerns that were brought up right out of the gate as soon as this was mentioned.
Mhm.
Would that
Yeah, no,
help?
that's great. And just one more time, I wanted to thank you for being God, I like shook the whole table. I wanted to thank you for being so patient because I know you brought that up this morning, and I knew there would be a great spot for it. So thank you.
Yeah, it happened to be my day off, so I was like, well, let's listen to these guys talk, and the fabrication that's happening there with Andrew is this is exactly the kinds of capabilities that groups like the Soybean Innovation Lab, their mechanization component, they're trying to create these sort of fabrication ecosystems in Africa, and they're training fabricators, in multiple countries to make very, very simple machines and to do kind of take what Andrew's doing and just take it down as simple as you could possibly take it, scale it as small as you could possibly scale it, and then create products that are transformative for post-harvest mechanization, et cetera. So,
That's
okay,
great.
so I'll share my screen and blast through some stuff if that's good. Okay, can you see this all right?
Yeah, we've got you.
Okay. All right. So, uh, my name is Eric Lane, and I am co-founder of Prosperity Systems. And what we've done is we've leveraged world-class engineering to develop a low-cost, multi-purpose farm vehicle with a new suspension system that can overcome Africa's road problems and help transform food production. So, like you saw with the university group, it's pretty easy to assume that our project has not taken into account the ecosystems around mechanization or local context. And it's like I said before, some of the problem is how that ecosystem is operating. Is business as usual working? Are there new models needed? And he mentioned that one of the models that's even changed in their mind is this idea that somehow farmers who can't afford a better hand hoe are somehow going to magically become machine owners, or groups of farmers who own a machine. And that has slowly collapsed under the weight of reality to where they're realizing that possibly the most viable model is service provision. So provision of mechanization and related services. So groups of farmers who are organizing are bringing in, companies who can do this. So that sort of sets the ground. Let me just blast through some slides and we'll see how it goes. You ready? So we reviewed over 4,000 pages of research literature, spoke with experts at the forefront of smallholder mechanization, and a couple of them joined the project as advisors. We've consulted with some of the top transport economists that are studying Africa, that have studied transport in Africa. And across the board, these are the three, key barriers that are preventing businesses from mechanizing over 30 million small-scale farms. And it tends to boil down to across the board. I mean, there's a laundry list of issues, but these are the biggest ones that come across from all the groups we've talked to across a dozen countries in Africa, to all of the researchers, to all of the experts, to all of the research literature. You're looking at inadequate roads or keeping machines out. Most of the machines that are available are not engineered for rural small-scale farming in Africa, where the plots are small, they're scattered, the terrain is uneven, the distances are vast, the roads are inadequate or non-existent. These kind of machines aren't necessarily engineered for that. And then what everybody was bringing up before, inadequate parts and service support. In many ways, the OEMs don't see small-scale farming systems as a market. So these dealer systems, they exist, the ecosystem exists, but it's under business as usual. It's not actually functioning that well. So just an example here is there's the Near-Sill tractor rehabilitation program in Nigeria, and you're looking at it, and this is one of the subcontractors for it. They figured out that it's actually a lot less expensive to fix the tractors that are rusting into the ground across the country. Well, that phrase right there makes you go, what? Yes, they're rusting into the ground across the country, and it's far more expensive to replace them than it is just to rehabilitate them. So their program is engineered and it's set up to rehabilitate 10,000 tractors a year for at least 10 years. That gives you an idea of the magnitude of the problem. And it's exactly what the university is saying. You can't just plug in a solution. You need an ecosystem for the solution. The existing ecosystem is not working. So, because of this lack of mechanical power through all these generations and these decades, it's fueling this poverty, drudgery, lack of opportunity that's driving record urbanization. They have the second highest urbanization rate in the world. Put another way, this means that, and you heard it from Levi, 60% of the farm power is human power. If they've got the second highest urbanization rates, that means the greatest source of farm power for a region that holds over 40% of the world's unused farm land is urbanizing out of the system. The power is going away. There are no roads to the majority of these farm fields, and decades of evidence is showing that there won't be. So there needs to be a solution, and this is why we created the Service Rover Vehicle, or the SRV for short. It tackles the three key things that I mentioned before. It's engineered to be locally built and serviced, which is a big piece of the problem. And so moving forward, I'll just look at what my next slide is. Yeah. So the next slide is, what is it? What does it do? Its suspension is derived from the world's first all-terrain supercar. Very unique suspension, nothing like it. And it's patented. And so a Africa version of this has been developed. This distance from here to here is over 7.5 feet. So it doesn't need roads to reach farms. It can operate on twice the incline. It can carry 1.2 tons up a 70% grade. This is what it looks like compared to other, machines in existence. The Toyota Hilux pickup is everywhere, and the big tractors are in most industrial countries, but they're not in rural farming systems. So what's our solution set? It's based on all of the research and the advising experts, and it was years of work to engineer this into the SRV. And so we had this all put together ourselves, independent of anybody else, outside of all of the people we were working with and all the research that we were doing. Turns out that we had our own list. And 6 months later, the FAO, the African Union Commission, the Malabo Montpellier panel report, using the same massive research base that we did and consulting the same experts, a big army versus a handful, this was what they came up with for strategies to mechanize Africa. So it's not like they created a bunch of boxes and we just checked them off. We had our solution set before they released theirs. We are perfectly aligned with the agendas to mechanize Africa. This is really important. And our business model and how we approach this is plugged into that kind of ecosystem thinking that's going on. So this is how we're looking at doing it. As I said, the vehicle is engineered to be basically an IKEA furniture kit. It can be built from simple kits and modified containers with low-tech tools, trainable methods, something that women and youth can be trained to do. Anybody that can understand a basic motorcycle, this machine is so simple. If you can understand a basic motorcycle, anybody who understands that can actually train women and youth to be able to operate this machine, to be able to service the machine, and eventually to be able to build it. Okay, so how do we go about doing it? It's engineered to ship in bulk. Our plan is to ship these manufactured parts in bulk to Africa, where African businesses assemble the parts into kits and outfit shipping containers to build the kits. This is not a fantasy. There are businesses on the ground who are part of the ecosystem that the university talks about. And some of them are building tractors and they're building vehicles from kits. These are mass manufactured in offshore factories. And so these African countries are exporting their jobs and their money in order to get these kits into their country. And there are businesses that they just build from a kit. So they already know what kits are. So what they want to do is, we've talked to those businesses, we've considered their ecosystem, and we've asked them, what do you think of this? And they say, we need to get into these rural markets. We don't know how basically, long story short, they want to modify and expand their business to be able to build these kits. They actually want to be able to do fabrication as well. So local content wherever possible. They want to even be able to provide local content into these kits. And so they see this as huge opportunity. They're acting in their own self-interest. It's capitalism. So what they do is they assemble the parts into kits. They outfit shipping containers to build the kits. They ship the kits and containers to our customers. And we'll get into who our customers are in a minute. And our customers will build and service their own fleet for a machine that allows them to provide the critical, essential mechanization services to the thousands and thousands of farms that they engage for production, and they aggregate and resell that crop. So that's kind of the customer in a nutshell. Why would we do it this way? Because it is in perfect alignment with these strategies for mechanizing Africa. It brings light manufacturing into Africa. This is a huge development goal with the countries and their donor countries. It distributes these critical, low investment machines, facilities, tools, and opportunities into these rural regions where they're needed most. This is spatial synchronization of development activity, which is another huge development objective. So in this case, that spatial synchronization is assembly, build, service, jobs, training, education, related infrastructure. And this is intentionally engineered so that women and youth can operate, service, and build it. These are our competitors. So what is actually happening? What's one of the problems that the vehicle solves? Here's one of them. These are competitors for off-road transport. This is what they cost to haul 1 ton, 1 kilometer versus a 2-ton truck, which don't go off-road in these areas. These are from some of the top transport economists in the studies that they've done. Now, when a crop reaches a road, if the road is degraded, which it usually is, the big trucks aren't coming either. And micro-entrepreneurs with consumer vehicles are hauling the crop. So what you're looking at is first miles transport for most of rural Africa. It's slow, expensive, unreliable. In the case of fresh vegetables, it damages crop, and the SRV can disrupt this. Okay, so moving along, what are the advantages compared to what you just saw? It can haul twice the crop at twice the speed for half the cost and double the number of farms that these businesses can access. Hauling crop is only one of 6 revenue streams that are possible with the vehicle. So they talked about being able to bundle your solutions in a way that works for local context. The vehicle is simply a platform that overcomes the largest hurdle, which is the roads and lack of roads. And then it can simply be configured as needed with these very compact Category 1 low horsepower implements. Why would you go in with such a small implement? Because you're going down trails. You're going down unimproved tracks. You need something that's very small and compact. So with these kind of compact implements, a machine like this can go farm to farm in roadless areas. So another problem we talked about that I heard everyone talking about was post-harvest processing. So here you have part of the ecosystem. Cold Hubs has solar-powered cold storage for fresh vegetables. They have scaled 60 facilities across 28 states in Nigeria that feed over 90 million people. They're losing 30% of the crop because of these transport issues that I talked about before it even gets there. Let's assume that they've solved the transport part and they're already building and servicing fleets of our vehicle. They have many, many farms that are producing grains, and those farms are requesting in-field post-harvest processing. And so one of the problems with that is even with a small thresher like this, transport is a massive, massive problem. So you say you have the right machine, but how are you going to logistically get it from farm to farm in these roadless areas? You're going to spend all of your time moving the machine and a tiny, tiny fraction actually making revenue. A machine like Soybean Innovation Labs multi-crop thresher, it's a big thresher. It can fit in the back of our vehicle. It's engineered for these kind of machines, and it can be powered off the rear PTO. We have a front PTO. We have a side PTO. So we can power 2 of these machines. And with our machine, this kind of processing equipment can go anywhere. Okay? CAMS Engineering is piloting 52 of those exact same threshers, and they're on the ground in Ethiopia. And their best solution isn't a donkey, it's the donkeys that aren't getting stuck. Okay, so that's how bad the problem is. All right, so moving along, our value proposition, if you look at this as an umbrella kind of idea, is we enable agricultural economic productivity without having to build or rehabilitate roads. Based on years and years of research and talking to the experts, talking to road agencies, I talked to the Tanzania Road Fund Board. And this is disruptive, and the implications of it are significant and they're far-reaching. So moving along, business model, how do we even implement this? We sell the supplies, rights, and support to build and service the SRV to African businesses who buy and resell crop. These businesses are scaling. They're almost doubling year over year, and they're scaling into a market of over 30 million small-scale farms. And there's many examples of them. Cold Hubs isn't even on here. These are just a few samples. But these businesses are having huge issues with upstream logistics. that generate these compounding costs and losses along the entire value chain. So a lot of these potential customers, they want to vertically integrate operations. We talked about a project that's actually trying to do that vertical integration. So they want to vertically integrate. Why? Because you have a lot of informal actors doing these very inefficient functions using inadequate technologies. If you can vertically integrate the money that you're able to save, there's plenty of rationale to be able to build and service your own fleets. Okay, that's progress. The technology is already proven, and our partner, we partnered with them. We adapted it for Africa. We built 3 iterations of this multi-purpose farm vehicle. We were constructing 2 before we ran into funding constraints. So without funding, we built a full-scale prototype of the suspension for Africa, the very specific one for Africa, and we've been piloting in a production 4x4 vehicle. So we've started doing MOUs. There are companies in 10 countries that say they need this yesterday. This director at Bear Global oversees Africa, India, and Asia. He said our innovation is sorely needed in seed systems. AgDevco has 120 million invested in companies in 9 countries. The director there said they have several projects that need this. So the real thing that's holding us back here, it's holding everyone back, is a demo vehicle and a pilot in Africa. So we've gone as far as we can on our own to build, test, validate, and ship a demo vehicle in Africa. It's around 300,000, takes up to about 1 year. The pilot in Africa varies from almost free. There's probably half a dozen groups that already want to pilot this. They're ready to pilot that. They're funded to do something like this. We just simply don't have the vehicle to provide them. So that's the near future, and we have a long-term roadmap available. And that's basically everything in a nutshell. I'm happy to cover other stuff. I mean, I'll look at team just so you can understand who was involved in this. I did strategy and research for the consumer version of this hyper-efficient vehicle. It won a global competition. It's in the Henry Ford Museum. I co-founded it with Ron Mathis. He designed that vehicle. He designed world championship race cars. He led engineering for this Space Plane project. So when I say the project, we've leveraged world-class engineering. We're not kidding. I'm not kidding when I say that. Ron was about to start technical drawings when he was killed in an accident. Most of his work died with him. I had to find my way back from that. And the way back was our current partner, Cores Engineering in Athens, Greece. Before partnering with us, they developed the enabling technology across 4 prototype programs. So Cores Engineering has the team, facilities, and experience to execute the innovation. They've already done it with far more complex machines. And if I were to look at some other stuff, there's the economics. This is some of the engineering if you're liking that. I'm not an engineer. It just happens that world-class engineers like me for some reason. So there were already 2 technology demonstrators. And then Cores Engineering was going after a recreational vehicle with their technology. So long story short, prototype, proof of concept. Then they went into the production prototype of an all-terrain supercar. You can look at the extent of this engineering. It will melt your brain. The transmission is 3 stages, 18 forward gears, and it fits in a tiny compact space, and all designed in-house. So incredible engineering. And the culmination of all of that was the all-terrain supercar. The question was, this technology overcomes some of the largest constraints holding back agriculture in Africa. How do we adapt it to African context? This was a huge engineering undertaking, going from super complex to super simple with just a handful of parts. And so that kind of is the road. That's where we've been. And I hope that that is useful information.
Wow. Wow, I'm blown away. And I think I see that a couple of other folks are too. I know Elcano and Sergio both have questions and comments. I'm going to pull an audible here because I think that this conversation around what you're doing, Eric, and what Andrew's doing, I think that's really of interest to a lot of people who are on now and will be watching this virtually later. So what I want to do is I'll just really briefly, I'm going to stop for a second. I'm going to jump into the next session. And I say briefly only because there are a couple things on the slide I've got prepared that I'd like to share in regard to the financing piece. But I'd rather skip that session almost entirely because a lot of what I had to offer has been talked about, where this equipment can be locally manufactured, locally put together, as well as owned by farmer groups. So there's really only a couple things I want to touch on. And then what I want to do is I want to come back and I want to just have this conversation with you and Andrew. Anyone else who wants to ask questions, I want you to be able to raise your hand, ask them rather than me just moderating them. And we can even go until another hour. I can go as late as 2:30 Central, which would be a half an hour beyond our original ending time, if you guys are amenable to that. So just let me quick pull up my slides here. And there we go. Okay. Okay, so just really quick, talking about financing and ownership. Access to capital is something that is going to require a whole other conversation with some folks within the banking industry that we don't have with us today. So aside from just identifying that it's a problem, is the most I can do today, really. But it's one that we do need to be thinking about in future conversations. The engineering, that's what this conversation we're about to have with you guys. That's part of it, of course. Affordable manufacturing. I love this kit standpoint that Eric talked about, where it can be manufactured somewhere else, but maybe put together there. That can help keep costs down. I also think the opportunity to partner with local fabricators can further bring the costs down, so long as you can control the quality of the equipment that they're producing, which is a whole other question. And then ownership, maintenance, and training. So let's talk about those things for a second. Potential capital partners, local and state governments, non-governmental organizations. Eventually, Sorghum United would like to be in that category of an organization that can provide funding. We're not there yet, but in the future, that's one of the places we hope to be. And then private sector investment collaboratives. One of our newest partners, by the way, is an organization called the Scoby Collective, SCOBY. I think they pronounce it Scooby, but being an American raised on Hanna-Barbera cartoons, Scooby makes me think of Scooby-Doo, so I say Scoby. At any rate, that's what they do. They're an international collaborative of partners, so groups like that that can come together and invest in projects in an organic way. Those are some areas in which we can look. And then again, we're talking about local empowerment. I really think that we need to be involving as often as we can local professionals, fabricators, et cetera, to keep costs down, but also to empower and encourage innovations, because there are always going to be things that need to be done on the ground or that could be made better that we may not be able to see from a bit of a distance. And then as far as ownership goes, I really love the model where a cooperative or a farmer producer organization or a SACO owns these, is able to cost share. But then that also means that they're going to have to potentially consider, some sort of a fee for members to go into a maintenance fund, which has to have some oversight as well, so that it doesn't become embezzled or something. Because when something breaks, you're going to have to be able to fix it. And if you can't afford to fix it, it's not going to get fixed. And if you don't have the people who are trained properly to fix it, that's a whole other problem. We also need to make sure that we're engaging all of our stakeholders in Africa in particular, where you have women doing the agricultural work, but not being involved in the decision-making. That's a real problem. And it's not just a problem from a gender equity standpoint. It's a problem from they're the ones that understand what they need on the ground. If they're out there in the field doing the work, but they're not being allowed to be at the table when decisions are made, it's highly unlikely those decisions are going to be optimal. So again, stakeholders also are local processors and aggregators. We've talked with a couple of aggregators today. They've got a stake in making sure that these systems work as well. So bringing them to the table, and then who's going to own the project? Who are the beneficiaries? Is it the entire community? Is it part of a community? Who's it going to be? And identifying those and getting those people involved is very important. And this, there again, we talked about this already. We've got to make sure that these solutions are sustainable in the sense that parts can be found and they can be fixed on the fly in the field by the people there working with them. as necessary. Otherwise, it is simply not sustainable. So with that, we just blew through the last session. And of course, I'm always happy to engage further on that, but I would like to see more of an engagement on this equipment and engineering piece that you guys represent, because I think it's very exciting. The one question that Elkanah has that I have as well, the thresher that you showed, Eric, was developed by the soybean folks. Does that thresher also work for sorghum and other small grains? And how fuel efficient is it?
Yeah, those are good questions for the people who engineered it. But from what I understand, that thresher requires about 15 to 18 horsepower to run, and it is a multi-crop thresher, and so it's designed to do as many different crop as possible. I believe sorghum is one of the crops, and our vehicle is engineered so that our vehicle can hold 8 different sort of engine platforms inside of it. So it could be various horsepowers, but essentially being able to run a couple of those is very significant. One of the biggest problems when you're running a machine that's pretty fast, pretty efficient, is you actually need enough people. You need a small army feeding the machine. You need at least 3 to 4 people in order to have the machine fully operating. So sometimes the actual number of people is a constraint. Is that helpful?
Yeah, I think so. Again, not having been the one that asked the question, Elkanah, I
Mhm.
would put that back on you. Is that helpful? And then again, anybody who would like to ask a question, either raise your hand or put it in the comments, and I'll serve as moderator.
Well, if I could say something real quick, Anthony said that they're partnered with Kerry Clark from SIL. Kerry Clark is a really big fan of this platform. The largest problem is being able to get an innovation like this moved up through the university ranks to some of the people who are at decision and policy making, because we have such a huge opportunity for integration and collaboration. But in so many instances, we get caught into this, what I call looking down straws scenario, and everybody is going, oh, mechanization is a tractor. Actually, mechanization is transport, and it's a critical piece, and they all work together. And what's great is the sort of the holistic ecosystem philosophy and reality is beginning to really take hold. And we are simply a piece. We don't have the ultimate solution for anything. We are just a very versatile piece that can be plugged into ecosystems. And we would love to do collaboration and communication, at least open up dialogue with people like Anthony. Okay, I'll stop there.
Okay, thank you. With that, we've got Elkanah, and then Andrew's raised his hand. Andrew, I think it's funny that you've raised your hand for your own session, but I appreciate you doing so. Elkanah, go ahead.
I really appreciate the question on the thresher being able to do sorghum for smallholder farmers was directed to Andrew, and he was to comment on the fuel efficiency. I want to appreciate Prosparity, the last presenter who's just done his presentation. He truly understands the challenges of the smallholder farmers in Africa, because currently we are experiencing a lot of rains, a lot of roads are destroyed. Reaching the farmers sometimes is a challenge. Getting the produce from the farm is a challenge. Getting the produce to the main road, because the rough roads, some of the roads are cut off. And I can assure you that product, the car would be outsold. You will not be able to meet the market. I want to give you an insight into the motor industry. I'm also a car dealer in Nairobi. This is a product that the market is just waiting for. because the kind of challenges we face as farmers when we want to get our produce to the aggregators, to the markets, we lose a lot of produce. Sometimes the bags get torn and the produce is lost, and sometimes the cost of transportation, like moving your produce with the Pro Box, is very expensive. So this is a product that we really do need, and I'm just praying that you do your job very fast. We are waiting for this product in this market. Otherwise, I'm very impressed. Thank you.
Great. Thank you. Andrew, go ahead.
Yeah, Eric, I got a question. So looking at the item that you've made there, and one of the things that I think is unique is obviously your team has discovered that every challenge you solve is presented with another challenge that needs to be solved, and it looks like it addresses a lot of those. Relative to some of the constraints from a cash standpoint, what's the plan to overcome that obstacle?
There are a number of different routes that are possible. Here's one example. Cold hubs, they were funded at $2.5, $3 million in donor funding to scale out their hardware. So there's donors or somebody who might be interested. It's a matter of getting our innovation and our message, up the flagpole or up the chain of command high enough for them to be aware of what Elkanah just said, that the market is ripe and ready for an innovation like this, and the market would be purchasing it more than likely. Now, into the deeper aspect of financing. Hello Tractor is a platform who is they kind of coined themselves as the Uber of tractors, and they hitched their entire business on a machine that is only used about 30% of the time in Africa. I don't even know if that percentage is correct, but the FAO crunched the numbers, and the FAO said the utilization rate for a tractor to be viable in Africa is 800 to 1,200 hours per year. And the actual utilization rate of tractors in Africa is 300 to 400 hours per year. And so that's part of what Hello Tractor was trying to overcome, was how can we get these tractors to be used more often? And so they realized that that's what they need to do. They need to book these tractors like an Uber and have as many people using them as possible. But then they ran into the reality that Africa has the lowest tractor penetration, some of the lowest tractor penetration in the world. So they simply needed to get more tractors onto their platform. Boom, we're right into financing. And that's a hurdle they couldn't overcome on the ground. And so they went, well, can we come up with a model, a financing model that would enable people, entrepreneurs, to be able to get a tractor funded? And so another donor stepped up, Heifer International stepped up, and they stepped up with multiple millions with a funding mechanism for entrepreneurs to be able to fund a single tractor. There's a qualification process. It's somewhat complex, but it works. So they're managing to scale one tractor at a time financing. This is the access to finance problem, and they found a key, a small key to it that unlocks one tractor at a time. Our innovation allows scaling fleets at a time. So if the same key were to be applied to what we're doing, you could actually fund a business that scales fleets, that builds and scales their own fleets. So is that helpful at all?
Yeah, I mean, I think one of the challenges that they're also going to come across that we see anytime you have a co-op is that oftentimes people all need the tractors at the same time, right? I mean, there's that's the difference oftentimes of cars versus tractors, is the seasonality and the challenge of overcoming that when you've got this massive influx in during planting, tillage, harvest, and then virtually no need for many months of the year. And I think that I wonder if that has something to do with the reason of the low utilization of hours on tractors, because we see that here in the United States, where most tractors sit in the shed most of the time.
And you take our planting window that we have in many other countries, and in Africa, it's very compressed. It's a very, very small window. So it's the utilization you're talking about, which is already low. In Africa, it's crunched into even a lower utilization. And because of that, I mean, we talked to Origin Group, and they spent $10 million that didn't really work, scaling out all of these tractor depots, only to realize that all of these multiple 200 tractors, that they actually weren't working enough hours of the year to pay for themselves. That's partly why our machine is designed the way it's designed. It can do light tractor work, but then you can use it the rest of the year.
Mm-hmm.
It's the kind of platform that can survive in this kind of utilization, almost nightmare that you have going on in Africa. Is that helpful?
I would actually
Yeah, and I think,
conjecture, I'm
yep.
sorry, Andrew, to interrupt, but I would actually conjecture that that's a huge opportunity there in Africa, because if they can use this on the farm, but then it's going to also give them reliable transportation throughout the year, not only to bring things to market, but hell, to take the kids to school. I mean, just anything. If you can do that, you've really hit something. I mean, not to get too excited without knowing more, but I do think you've got great potential in your product. I've got a question though, for you, but also for Andrew. And that question is, I saw that you can attach implements and things like that to what you've got. I know you're not an engineer, so maybe you can't fully answer this, and I'm not an engineer, so I can't fully ask it. But I guess what I would want to know from you and Andrew is, given the specifications or the specs that are on their existing on the platform itself, what other kinds of equipment can be designed to be attached to it, just like Andrew's family has been designing these different kinds of adapters for generations now.
Well, Andrew, this is a great question for Kim, and I can follow up. Go ahead.
Yeah, well, I guess I actually look at this machine a lot like we looked at tractors early on in agriculture in the U.S. as mechanization began. We saw a lot of tractors that really were the start of combines, where you attach these different implements to them, and then that basic framework of that tractor, which is an all-terrain vehicle type system, ultimately can carry that piece of equipment. And I think that's how you start to scale this up, is you start mounting small pieces of equipment to this type of machine. And then as the volume increases, soon the machines start to increase in size and scale, and then it continues to rise. So to me, this looks like really a great opportunity to attach anything to it. I mean, I don't see why you couldn't mount maybe a one row header with a threshing system on the back of this. On the back of this machine. So it looks like a very versatile platform.
Eric Snow wants to know what the clearance height of the machine and ground clearances are.
Yeah, the ground clearance, I would say it's probably around 14 inches. It might be significantly higher because the differential is not located between the rear wheels. It's located more centrally in the machine. They're very long trailing arms going out to the rear wheels. And I think a lot of the secret is about how you navigate around obstacles without getting stuck. So that's part of it as well. And that really boils down to what's the articulation range, and can you actually sustain traction through the articulation range. So I'm not sure if they're talking about clearance in terms of we want this to be a sprayer, we want it to be 3 feet high to get over the plants. It's not going to do that. But if you're talking about clearance in terms of being able to overcome poor and damaged roads, this is fully capable. And what's really interesting about how the suspension works is you don't need massive traction, I mean, massive clearance to achieve that. You need massive articulation with full weight on each vehicle, which maximizes your traction. So it's that combination of articulation and traction, which is really the key to overcoming the road constraint. I hope that helps.
It does. And Michael also just noted that cultivation equipment obviously is a valuable capability. But speaking of capabilities, and as we get closer to the end of our call here, I would be remiss not being a 30,000-foot person, or not, to not mention the potential, and I'm sure you have already seen this in markets outside of agriculture for a vehicle like this. Think about search and rescue. Think about archaeology. You think about these areas that are very difficult to access. Just this last weekend, we saw that the helicopter carrying the Iranian president, of all people, went down in a very remote region. So the ability for rescuers to access these difficult regions. I'm not advocating for the Iranian regime, just for the record. I'm neutral, but would be a huge additional market for this kind of a vehicle that you've shared. And I'm so impressed that you joined us, because this is out of the blue for me. I had no idea.
Yeah, it's kind of a lightning bolt out of the blue.
Yeah.
I didn't mean to
No,
storm
I'm
in
glad
on
you
everything,
did. No, I'm glad you did. Yeah.
but it applies to so many different things like you just talked about. But to back up to implements, it's designed to be 50 horsepower or below, which puts you into the category 1 implements or class 1 implements. And there's like a universe of these in the Chinese and Indian markets. So there's no real issue with having access to implements that are power matched to this machine. It's a matter of how well does that implement work in a local context. But this is engineered for the class 1 implements, and there are so many in the Chinese and Indian markets for the smaller tractors that we feel something that is, number one, we need them to be compact for the off-road component of it and to go field to field, but also being able to tap into that's the most affordable type of implements that you can get. There are programs that have spent years, with donor money and research institutes to come up with a cedar planter, and then they release it. And then what happens is everybody ends up choosing the cedar planter from India because it was the most affordable that did the job good enough to get it done. And so that's why we would prefer to tap into that versus something that's super specialized. And when you get enough fabricators and networks on the ground, and research institutes, usually they can adapt, and they've done a lot of this with cedar planters, adapt them better for local context. So that kind of feeds into what you were saying before. As far as the other applications, the World Food Program has a vehicle that they use called the Sherp. And it's a true off-road vehicle. There's nothing like it in the world. They're $100,000 a piece. And they don't really work on food security on the front end. They work on food security on the back end. So we are part of the prevention, but we're also part of the access. And so if you have businesses who are building and servicing their own fleets because it's in their best interest, they can quadruple the amount of crop they're receiving and the quality of the crop. If they're businesses that are already building and servicing those fleets on the ground, then the fleets exist for the World Food Program to contract for all the different reasons that you mentioned. They're already there. Right now, they're putting these Sherps on giant planes and flying them all over the world at $100,000 a piece. What's the cost of that versus having local businesses on the ground that are using these vehicles all year round? And if a disaster strikes, well, there isn't any food production, and you have to figure out, you have to start working in that mode. And this is a kind of machine for that. I hope that helps. As well as, I mean, one of the big issues in Africa is pregnancies, complication pregnancies in these rural areas. And they're putting, if the woman is walking, or she's being put in a wheelbarrow, or if you're lucky, there's a motorcycle ambulance and she's put in a sidecar without any suspension, and she can actually get thrown out of it. Imagine if she could be put in a vehicle that's already in the area being used for farming and taken safely and smoothly. These I've ridden in the P3 prototype. It takes a road that would normally knock your teeth out and makes it feel like a graded dirt road. And for pregnancy, emergency medical kind of hauling people around like this with the women, it's a game changer for that, for lack of a better word. I hope that helps.
It does. And for many of us that complain about the potholes in our own cities, I wonder if you can put the suspension on my Camaro. Just another couple of questions. Anthony's got his hand up, and then we'll start to wrap up here.
Right. Yeah. So like everything, it's like it's one of those situations where for me it's like it sounds too good to be true. And I'm like trying to figure out what is like right now your biggest constraint, right? Like you were talking about running it up the flagpole. Like what is the obstacle that you're like really encountering with this? And like is there like a way to like open source this information to make it easier for local manufacturers to like build this? Like I guess like what resistance are you running into? Because this sounds like amazing, and I'm just like in awe of it. I'm just like, why isn't this being adopted? You know?
Yeah, the very short answer, Andrew, is that programs are not structured for this innovation. There is no grant program or grand challenge program or grant challenge program to design a off-road multi-purpose farm vehicle. Doesn't exist. Programs are not engineered, they're not structured for this. And so they're structured for piloting. So if you have one on the ground, they're structured for piloting, they're structured to facilitate adoption, they're structured for everything except actually building it. And when we've consumed, over the course 15 years, $3.5 million, and now we're looking at, we would love to build this fifth vehicle, and it's super, super simple, but it's very expensive to do it. It feels like, haven't we come far enough? Isn't 4 vehicles, 3.5 million, decade, is 98 of 100 steps to get an innovation on the ground in Africa? Is that enough steps? Do we have to make the last 2 by ourselves? We would rather make step 99, which is building the demo vehicle and validating it in Greece, very close to Africa, and step 100, piloting it on the ground. There are groups that want to pilot, but we're stuck. We're stuck here because there are no grant programs structured to build this thing. And this is where dialogue is what's going to happen. And that's why I'm here. I'm here to have dialogue with Andrew. I'm here to continue dialogue so we can talk about ways, how can we get a demo vehicle built? This isn't a prototype.
Right.
A prototype
And
is
all you need is
engineered
200 grand, right?
It's actually about 300
300.
because we need to support it during a pilot as well.
Okay.
And so, but back where I was saying was they're not really structured for this. And I think that's our biggest challenge, and being able to get the dialogue going about what are the implications when you can get it on the ground. I mean, I've run the numbers. When I said twice the crop at twice the speed for half the cost, when we received a lot of data from cold hubs about how their upstream transport is happening. When we applied the numbers, we came up with 4 times the value delivered at 1/4 the operating cost. And that was a conservative estimate. We took 500 kilograms out of the capacity of the machine. We had it going only half of the MPG. We did all these things to try to handicap it. We made it 4 times more expensive than what's on the ground right now. And no matter how we handicapped it, we came up with 4x, not 2x. And so, yeah, I mean, I could go on, but really, Andrew, I really want to be able to have ongoing dialogue. Our dialogue with Carrie has been great, but they're very constrained in how their program is structured for mechanization. It's not really structured for an innovation like ours. They're chasing the thresher, and that's their biggest thing. But how do you get that thresher moved around? Are you using donkeys? I mean, yeah. So is that helpful at all?
Yeah.
Oh
Andrew?
yeah. Oh well, and I'll tell you to. Sorry, Anthony. But yeah,
Anthony,
completely
sorry.
honest. No, it's okay. We have an RFP in, I think, July, so that'll be like our first kind of round of RFPs. So, I have. Thanks for putting your email in there. Like, I'm super interested in this. So I'm the manager of the lab. So I don't make any of the like funding decisions, but like this is
Yeah.
certainly one of those things that I'm gonna kind of like slide and be like, do you guys know anything about this? Because it's really cool. And again, we know Carrie, and Carrie's awesome. So yeah. I'm very, very glad to, even if
Talk
I've
to
just
Carrie
met
and
you
she
in this
will,
conversation, super
yeah,
worth it for me. So like I'm stoked right now. So yeah, much appreciated.
talk to Carrie and she'll go, we got to figure out how to get it going. And so we've done our work, but we're seeking those partners. And
Cool.
yeah, I mean, Anthony, I would love to keep our dialogue going.
Perfect. Excellent, my
And
man. Well,
yeah,
follow us on social media and stay
and I'll
tuned.
use that as a transition, actually. I hope we keep our dialogues all going after today. I think it's been a really valuable conversation. I hope you think it's been a valuable conversation. Whether you're with us still live, you've been here all day, like several of you have. I know a lot of folks have had to jump out. Again, time changes are time changes, time zones are time zones, and schedules are schedules. But if whether you're with us live, watching it on YouTube later on, whatever it is, I hope it's been really valuable to you. I think it's very important that we continue the dialogue, and with the permission of our speakers, I would like to be able to share their email addresses as well when I send out the video recording and the other resources that we've shared. I want to give a very special shout out and a thank you to all of the folks who have been a part of this today. I'll throw Sharmila Oswal and Mahesh Lande a big thank you, even though they weren't able to join us, because their commitment to be able to join us meant a lot to me. And I understand the time change between here and India, that's a difficulty. But thank you to Crystal Phillips, Dr. Diallo, Mr. Levi Chicombe, and Mr. Marcelo Souza with Agricola for our panel discussion. Thank you to Dr. Ankit Chandra and Anthony Delaney with the Dougherty Water for Food Global Institute. Of course, thank you also to Andrew Bish and to Eric with Prosparity. And, again, thank you to everybody who's watched, who's asked questions, who's engaged, who's been a part of this. Today went exactly as I hoped it would. And what I mean by that is nobody came in here with, hey, this is the way things have to be done. Instead, this was a conversation about, hey, let's come together and let's just talk. Like Crystal said, these are problems that seem to be very common and similar wherever we go. It's going to take groups like ours coming together to find the solutions then that can be applied in those other geographies. And to do so in a respectful way is fantastic. So again, thank you, everyone. We'll look forward to having another one of these conversations, maybe in 3 or 4 months. Maybe we'll do this once a quarter. And in the meantime, I hope the conversation can continue offline. So thank you.
Thank you, Nate.
Yes, you're welcome.
Thank you and bye.
You're welcome.